Hello everyone and welcome to a very quick review bite on exponents and exponent properties. To review the meaning of an exponent, which is a whole number, if you have a quantity like b to a power n, then this represents the base b multiplied by itself n times. For example, if you see an expression like 3 to the power 5, then you take 5 copies of the base 3 and multiply them together. It's also possible to have an exponent which is equal to 0. In general, we agree that if you have a base raised to an exponent of 0, b to the power of 0 simplifies to 1. The only exception is if the base and the exponent are both equal to 0. It's hard to come up with a number that makes sense for this quantity, so we generally agree 0 to the power 0 is undefined. It's also possible to have exponents which are fractions. If you see something of the form b to the power and the power is of the form 1 over a number, then this represents the nth root. For example, if you have 64 to the power 1/2, then that is equivalent to the second root, or the square root of 64, which is 8 units. Additionally, if you have something of the form b to the power m over n, as opposed to 1 over n, then the denominator of the exponent represents the root, and the numerator of that exponent represents a power. For example, if you take the number 64 and you raise it to the power 2 over 3, then the 3 in the denominator translates to taking a third root of 64. And the 2 in the numerator represents taking a second power. So this would be the second power of the third root of 64, which is the second power of 4, which is 16. It is also possible to have negative exponents. And if you see a negative exponent, then that is the signal to take a reciprocal. For example, if you see 3 to the power minus 2, then this is asking you to take the reciprocal 1 divided by 3 to the power 2. So that would be 1 over 9. So as a takeaway, it is possible to represent reciprocals and roots and combinations of reciprocals and roots using exponents alone. And you will probably remember this from Calculus 1 because this was a very, very important tool to allow you to apply the power rule to lots of different functions. We are going to be using a similar power rule, not to calculate derivatives, but to calculate what we call antiderivatives as we use the fundamental theorem of calculus to help us with integrals. Now, additionally, there are 3 exponent properties that I recommend that you memorize if you haven't done already. So the first one that I expect you to memorize is that if you have x to the power a and you multiply that by another x to another power b, then in total that will be equal to x to the power a plus b. So this product at the level of the base becomes a sum at the level of the exponent. If you have x to the power a divided by x to the power b, then that division becomes a subtraction. And if you have x to the power a quantity raised to the power b, then that's equivalent to x to the power a times b.